The noise level N at a distance d meters from a single sound source of loudness L is given by this formula. So a lot of jazz, don't get annoyed by the word. Remember, you're in advanced. So just saying N is equal to L over D squared, where L is loudness and D is distance from a single sound source. Two sound sources, there's two of them, L1 and L2 are placed m meters apart. Yep, I can see that. But the point P lies on the line between the sound sources and is x meters from the sound source with loudness L1. So straight away when I see this personally, I think back of like my year 9, year 10 stuff, and like a perimeter area topic. If something was M here, this was X, I straight away go, I don't know if I'm going to need you or not, but since I'm here and I'm thinking about it, I might as well write it. I don't know if we're going to use it, just so you guys know. But we write it. We might never use it. You guys have seen me do it all the time. You've seen me do my math. I just put things in first before I start. Write down a formula for the sum of the noise levels at P in terms of X. Fair enough. Noise level. There's the formula, right? N equals L on D squared. So don't go, Sam, how do I find this noise levels? Don't do that. Just N equals, what's this? What's L for the first one? L1. On, what's D? What's the distance? X plus L2 on, I'm not going to expand. I don't think you should either, because you never know what's going to come up. That was easy. So that means double I is going to be hard. Just be aware. But again, as you're learning it at school, I think some of you are starting it. Apparently, I think you're starting this as your next topic, or whatever. Anyways, if you do this at school, don't even look at stationary points and points of inflections. Don't even care about that. All you care about is maximum problem, and you don't want the baby ones. You want these ones, because these are the ones that are going to really differentiate you from the guy that's sitting next to you. So, let's do it. I think, do we need to read it? What's double I essentially saying? Just do it, right? Double I is pretty much saying differentiate, make it equal to 0. In this case, I think it's saying it's a minimum. Whatever. Let's just do it. Here we go. dn on d what? Okay, good point. Good point, because I think I was looking at it going, well, there's a lot of letters. What letters are constants and which letters are variables? L is a constant, correct. It doesn't change. M, also a constant. M doesn't change. X changes. X changes according to where P is. True? If you don't agree, yeah. X meters from the point P lies on the line between the sound source and X meters away from sound source. So we don't know how far the X, it can move. But the others are all constants. So dn on dx must equal to 0. All right. What am I going to do with n firstly before I start? L1 x negative 2 plus L2 m take away x negative 2 equals negative 2 L1 x negative 3 negative 2 L2 m take away x negative 3 times negative 1. You make this equal to 0. We're left with negative 2 L1 on x cubed plus 2 L2 on, don't run away from this. I said that to you guys last week. So when you see some derivative of the inside, chain rule. Just because it looks hard, don't run away from it. Unless you're extension 2, you might not see this as much. It's still good to know for your own math. 2L2 on equals 2L1 on. What do I do now? I'm not going to expand, because if you say expand this, I'm going to all of a sudden have x cubed, x squares, x's. That thinking of polynomials, you're overkilling it. So stop. What did you say? Cross multiply. 2L2 x cubed equals 2L1 m take away x cubed. So if I don't expand, what the heck can I do? There's only one other option. Cube root it. If you're not going to expand, you better get rid of it then. Cube root it. Cube root 2L2 x 2 cube root 2L1 m take away x. What would you do now? I think I might have given you guys room in the next page. Yes, I did. So don't feel like you need to squish it in. What would you do now?
Divide by cube root 2L.
This one here?
Yeah.
Yes, but do you see I still have x on this side? Usually when we're solving, we would want x's on one side. So what are you going to do other than, you're going to first multiply this in, expand. So it's going to look like this. Cube root 2L2x equals cube root 2L1 m minus cube root 2L1 x. If you guys are wondering why I keep doing this to my surds, is because it tells me stop. That's the end of my surd, and then there's an x. The x is not inside my surd. Now what do you do? I think it's pretty straightforward after here, right? What are you going to do to this? You're going to, say it again? Yep, so you're going to plus it. X is on one side, so cube root 2L2 x plus cube root 2L1 x equals cube root 2L1 m. Factorize your x out, which looks like the question that I think we were just doing. Looks like there's two things, so factorize them out. Will look like this. And welcome to 99/100. Obviously, this is not band 6, right? This is state rank, not band 6. This is state rank. You want to come first in the state, or top 10 in the state, because that's still state rank. You've got to be able to do it like this. No letters, okay, no numbers, just letters. Boom, finished. Yeah, I like it. You should flip back, read the question. What do we do now? Sorry? What do you mean? Nature! Isn't it funny? You do all this math and you forget the second bit you've got to actually do. Nature. You've got to prove that it's a minimum. Or maximum, whatever the question said. All good? Here we go. Second derivative, is it worth it? Let me have a look. Yeah, actually it's not that bad. You could do y dash table. No, you can't actually, because it's freaking letters. You can, it's just that your conclusion better be perfect. So I'm just not going to do it through y dash, I'm going to do y double dash. Because I can see it's not that bad. That was dn on dx. All right, d squared n on dx squared. All right, here we go. Bring the negative 3 down, I get 6L1 x negative 4. That's plus 2, wasn't it? So then that becomes negative 6L2 m take away x negative 4. All right, very good. 6L1 on x minus 6L2 on. Okay. Sorry. Thank you. Good on you. And obviously it becomes a plus. So now it's all good. What are we trying to prove again? Minimum, right? So we want this to be greater than 0. Now, greater than 0, but why? Why can you say that's greater than 0? So you cannot just say it's greater than 0. L1, comma, L2, comma, M, sorry, yeah, mx power 4 and x power 4 are all positive. These guys, because of length. These guys, because of obviously powers of 4. Therefore, it doesn't matter what you sub in, right? And, oh, you know what, we might as well add m in here as well. In here, m is also positive, but it doesn't matter. So this itself is always positive, but we don't really care about that, because it doesn't matter, even if you subbed in a negative number in here, for x, it will still always be positive. And that's it. Therefore, min. And now answer the question. What did the question say? Sorry? Yeah, but L1 and L2 is the loudness, which is m meters apart. And loudness, the loudness is not going to be negative, I guess. They should have probably mentioned that. What can you do? The noise level n, yeah, that's bad from me. They should have probably said L1, L2 is greater than 0. I guess that's the only assumption you can take. L1, L2 has to be greater than 0. Two sound sources of loudness, L1, L2 are placed m meters apart. Yeah, you can't deny that. You're probably right, but L1, L2 has to be positive. Min, and then like I said, what are you trying to prove? Find an expression for x. You've done that. Done. Therefore, the expression for x is this. For the noise level to be a minimum. And obviously that was a HSC question, so you can't say, oh, will it be asked? Can be asked. You just got to be prepared with it. Speed, part I was hard, double I was easy. Like I said, the opposite with loudness questions. The others, everything else is pretty stock standard. They're going to be like you just saw this year's paper. You just really do them. They're not problematic. Okay, we did that one last week. Any questions from the top ones anyways, before we think? That's it, right? Primitives just means integrate. There's nothing there for us to learn right now. Just this question here. Example 25. The diagram shows a rectangle ABCD inscribed in the region by the parabola y equals x squared on 4. I think it's page 28. Inscribed in the region by the parabola y equals x squared on 4 and the line y equals 6. Show the area of ABCD is given by that. All right. Again, just have a think first of everything you know. So think of everything you know about the area. So what do you need if it's the area of this? Obviously, what's your formula going to be? It's a what? Rectangle, so you just need a base and a height. So let's work out the height, because that might be easier. What do you know is this whole length? Six. Right? Why are you ever thinking that? That's 6. It says y equals to 6. Done. You see that? Yeah. What would you say is this length then? No, I'll do it. Not x. X is the where it occurs. Think. Don't over. No. Think. Let me see if I can give you a clue without giving the answer. That point that I've specifically said lies on the curve. It's not going to be a number, however. It's not going to be a number. What would that length be? 6 minus BC. Fair enough. Yeah, I want to find BC, so I don't want to do it that way. We actually want that length there that I've. It's really not hard. When I say it, you're going to get really angry at yourself. So I'll rather not say it. Think. You've got a graph. You've got an x value there. The value is 0 at x, but that's got nothing to do with anything. We want to find that length. What do you usually do to find y? How come you guys are not saying sub it back in then? To find that y coordinate there, you just sub in this x into this, which is just going to give you x squared on 4. That length is x squared on 4. Why? Because that point is x squared on 4. Right? How come you guys are missing that? X squared on 4. Let's say it's on the graph. If something's on the graph, what do you usually do? Sub it in. X squared on 4. Now, like I said, what's the length BC? BC equals 6 minus x squared on 4. Now, what's the length CD? 2x. And I think we should be done. Area equals 2x times, which equals, I'm just going to copy the answer because I think we have it. Now does that make sense? Guys can't miss that stuff. You're thinking of a parabola x, I'm just giving you the y value. That y value, just sub it in. Oh, sorry, the x value. I'm giving you the x value. It's interesting though. I can see where you guys are going wrong in your heads. Like, because as soon as I said, what do you do with the graph? You said sub it in. I guess I've just got to close that gap. When you see that length of y, it's the same as saying it's the y coordinate. If I had asked you, go and find the y coordinate of C, you would have found it. I know you were. It's important that you start seeing things like that, like in general. From now on, when you're saying, sub something in, don't just see it algebraically, also see the fact that when you sub it in, you're actually finding this value. That's what you're finding. You need to see it like that. All right, anyways, get rid of that. Done, and then obviously I think you guys know what you're going to do for the next one. Show the areas of maximum, double I, just differentiate, dA, 1 dx equals 12 minus 3x squared onto equals 0. Times everything by 2, you get 24 minus, or equals eventually, 3x squared. I'll go a little bit faster. Divide by 3, I get 8. Eventually you'll get, you guys take it at your own time, you don't have to go so fast. You'll eventually get x equals root 8. You can't have negative again. D squared a on dx squared is negative 6x on 2 at root 8, at x equals root 8, you get negative 3 root 8, which we know is less than 0, therefore it's a max. Just pause, go back up. The question says find the dimensions of the rectangle. We did not find the rectangle. It would be 2x and, what did we say here? 6 take away x squared on 4. So your dimensions are 2 root 8, 6 take away 8 on 4, which is 4. So that's the answers we're looking for. Dimensions. Happy? Easy. Done. We are done. We are officially done.